housekeeping. Some of you may have been familiar with the old company I worked for called Agro K. Agro K was a mom and pop company based out of Minneapolis, Minnesota, so all the products were manufactured in Minneapolis, Minnesota. I worked for this company for 10 years. Prior to that, I was a crop advisor in BC, working on everything from raspberries, strawberries, and blueberries to apples and grapes and everything else for about 25 years. So all in total, I've got about going on 32, 34 years worth of crop input experience. Back in about 2023 though, Agro K got purchased. So what was Agro K is now this company called Rovensa Next. Rovensa Next North America. Now that's a name change for us, and we'll see the branding change on our products moving forward as well. They will still be known by the product names and everything else, but rather than having Agro K on the box, it's going to be a green box and it's going to be this fancy term called Rovensa Next. But one of the other neat big changes for the company is we've gained on our distribution network. So for those of you that were interested in the past would buy some Agro K product, you might have had to go all the way to Minneapolis, Minnesota to get it. Some of you, I know I kind of pointed you towards Alberta, where we had a smaller distributor out of Alberta helping you out. Well, with some of this change, we have gained our distribution network. We now have Vandel seeds available right here in Manitoba. You have to coordinate with their rep Warren to make sure that he's got the product when you need it. So a little bit of pre-planning would probably be very appreciative. But Warren is with us today at the back of the room. Warren, can you give a wave so everybody knows who you are? Perfect. So we now have a local source of our products available to you, which is Warren. So now moving on with my talk. I start off by liking to explain to everybody why. The why I do what I do. And what do? I get to travel all over the place. I get to travel literally from coast to coast. Every once in a while I get down into the States, and periodically I've had the privilege of traveling overseas. I do business overseas with accounts in New Zealand, Australia, and as far away as South Africa, and I've been there a couple times. And I get to talk to a lot of farmers. In a way, I see myself as a bit of an information broker, in that I get to listen to the farmers over here and glean their knowledge and share it with growers over here. So really, I get the privilege and honor of meeting a lot of good people, learning from them, and then sharing that knowledge with others. And the why I like to do that is when I hear comments like this. When I hear things like, geez, those apple trees, they are the healthiest on the entire farm. Here's another one. This block looks healthier than everything else I have. This tells me that something we're doing at the farm from a point of view of an agronomy perspective, from a farming perspective, is clearly working, right? This is what gets me going. This is what gets me out of bed in the morning. When I hear from farmers, things like, you can see the difference in the field. We did something different. We changed our approach a little bit, and it helped us get a bigger crop, a better crop, however you want to define better, whether it's had more shelf life, or the berries were tastier, or bigger, or redder, however we want to look at it. You've had some success. When you succeed, we succeed. And when you succeed, I kind of get excited, because that's what gets me going. That's the why I do what I do. Now the what behind it, what I do that delivers on that why, focuses on what I call 5 fundamental principles to crop nutrition. Everything I do is based on these. So I'm going to spend a bit of time today talking about these because they're that important to me. The better we can apply these, the better the outcomes. And I'm talking about applying the right nutrients at the right time, right form, right mix, and right place. And I'm going to give you a little bit of an understanding of what I mean by each of these. Right nutrient at the right time. That's being committed that when I'm growing a crop, whether it's strawberries, whether it's haskaps, whether it's apples or raspberries, onions or potatoes, I want to make sure that I'm being committed to making sure that I'm providing the nutrients when the crop needs those nutrients. Are the right nutrients there at the right time to meet the needs of the crop? Bit of a challenge because every nutrient has a role to play. And so different nutrients are kind of needed at different times. If I'm thinking about strawberries or raspberries and I'm thinking about bloom, well, when I come into bloom, I'm going to be thinking a nutrient like boron. Boron has a role to play with bloom. It helps with pollen viability, health of that flower, and making sure I get a decent fruit set. So boron has a role to play at that point in the season. Now, if I'm not in bloom, if I'm getting ready to pick those berries, is boron overly important? Not so much. Now, it has a role to play, don't get me wrong, but it's way more critical coming into the bloom. So we need to understand how all these different nutrients have a role to play. And guess what? Which makes nutrition, from my perspective, a little bit more challenging, but a little bit more fun, is the fact that all these nutrients are interconnected. There's a lot of synergies and antagonisms I'm going to talk about. But every nutrient has a role to play. So don't get stuck in the trap of thinking about N, P, and K. Nitrogen, phosphorus, and potash. Because guess what? That's the beginning. That's far from the end. We have a whole host of what we call secondary nutrients, and then a plethora more of micronutrients that all have a role to play. And quite often, it's that micronutrient that can influence how well that plant's going to use that macronutrient. So there are key micronutrients I'm going to talk about today that are critical for that nitrogen to actually be used by the crop. And I've had cases where people thought they had a nitrogen deficiency and it was actually a micronutrient deficiency. And they kept pouring on more and more N and not getting a response. They were literally polluting the ground with N, taking it out of their back pocket of the wallet, and it wasn't moving the needle. What they really needed was a micronutrient. And as soon as they put that micronutrient on, that nitrogen deficiency disappeared. Less can be more, even with fertilizer. And this is from a fertilizer guy standing up here telling you that. Less can be more. So, when we talk about fertility at the right time, we need to be aware of the plant's growth stages. We need to be aware of the roles the different nutrients play at each of these different growth stages that the crop goes through. So we do, as a farmer, have to have an appreciation for this. And that's what I mean, making sure we get the right nutrient at the right time. Early in the season, the crop needs very little potassium. It's probably getting most of the potassium it needs right out of the ground. Later in the season, when I'm really trying to bulk those berries up and build some color, build some sugars, get some sweetness to that fruit, I'm going to need a lot more potassium. But early season, not so much. So we really need to be paying attention to this beyond. We often do this for disease and pests, right? We look at the disease and pest cycles and correlate it to what stage the crop is at. So at this stage, I'm going to see this disease. At that stage, I'm going to see that insect show up. I just know it. It's going to happen. It happens every year in that stage. Well, what I'm proposing today is the same thing as said about nutrition. We need to be thinking about, at bloom, boron, calcium. At color, as I'm pushing color, potassium. We need to be thinking about these nutrients based on the time of year and the stage of the crop. Now, I have a colleague in the States that is also a farmer, and he likes to correlate this type of stuff to the motor, to the engine. The engine being the crop, right? So how does all this correlate to the engine? I'm going to give it a try today to see how I do in regards to correlating the different nutrients. I'm going to walk through this relatively fast. When we think about nitrogen, a lot of think about nitrogen, think about growth. Now, nitrogen is one of the nutrients that is one of the fundamental building blocks of every part of that plant. So yeah, it's pretty critical, but it's a building block. It's not driving the energy of the crop. When it comes down to cells, it's actually causing cell elongation. Those plant cells that form, those fruit cells that form, nitrogen causes them to stretch and get longer. Now, if I put on too much N, think of it as taking a balloon and blowing up that balloon to the point that what's going to happen? Eventually, if I blow up a balloon too far, what's going to happen? Right? Pop! It's going to make a big loud boom, and the balloon's going to be in tatters. Well, guess what? Your cellular structure can do the same thing. That's how we see a lot of disease pressure coming into play. Over applying the nitrogen, causing those cells to really stretch beyond their capacity, and they're exploding. And then we have wonders why we have disease and insect issues. We're putting on too much N by and large. And this afternoon, I'm going to talk about a tool that you can use to help guide that process. Phosphorus. Now there's the energy of the plant. The electrical system, the battery of that driving that motor, same thing in the plant. Phosphorus has everything to do with energy transfer. Whether that energy transfer is pulling nutrients out of the ground, or have we heard of that thing called photosynthesis? Kind of where the leaf is functioning and using sunlight to make glucose, to make its food, right? Green leaves making food, photosynthesis. That is an energy transfer. Guess what? Phosphorus has a pretty big role to play in that. So when is phosphorus going to be needed? Well, phosphorus is going to be needed early, just like phosphorus. Phosphorus is part of that building block. Nitrogen is part of that building block, right? Plant parts. Phosphorus is driving that energy. So early season, phosphorus is pretty darn important, particularly if I want larger fruit. If my fruit size is smaller, putting on N, it's going to give you larger fruit, but it's going to give you fruit that's going to be fragile. It's not going to store well. You're going to have botrytis and all sorts of issues with it. Phosphorus is going to help drive that early cell division when that fruit is forming. If I can drive cell division, now I have more cells that don't need to bulk as much, which means I can have bigger fruit without having those disease issues quite as prevalent. So phosphorus drives the energy behind cell division. Phosphorus drives the energy behind using all those different nutrients. Phosphorus drives the energy behind using the sun to make food so the plant doesn't starve and it can actually produce a crop for us. Now potassium. Well, potassium is the coolant system, the air intake, the exhaust. A plant breathes, right? We have respiration, we have transpiration. That all happens primarily in the leaves. These little holes on the bottom of the leaves called stomata. And those stomata open and close, open and close. There's the cells around the stomata, they're called guard cells. Those guard cells swell up, the stomata close. They shrink down, the stomata open. Potassium helps drive that process with those guard cells going rigid and not rigid, rigid and not rigid. So potassium drives the coolant system. So in the summer months when it's starting to get hot, do you think potassium has a role to play? Right? Yeah, exactly, because it's getting hot. I need to combat that heat and that weather. Well, potassium's going to help do that. Now, one of the other things potassium does is it drives the movement of sugars. When do I want to see the sugars really move? Into the fruit during color, right? If I want big fruit and I want nice colored fruit, I want strawberries that are tasty, not California ones. I want some real strawberries, right, that have some flavor to them. I can say that I'm Canadian. Hey? Potassium is part of that. As long as I've really helped that crop along, so those strawberries have really supported early season leaf function, right? So that I had good photosynthesis producing sugars. Later in the season, as those strawberries are starting to bulk and starting to color, potassium can then move those sugars from the leaf into the fruit. I have a greenhouse strawberry grower in Atlantic Canada that I work with. They're growing strawberries in cocoa peat in a Cravo greenhouse. And they had their strawberries were so bitter. They look beautiful, by the way. They were beautiful, big red berries. Kind of remind you a little bit of a California strawberry. And they tasted as good too. And I mean that as sarcastically as I can say it, because you couldn't eat them. We measure the taste with bricks. And the typical bricks on a strawberry, so the overall insoluble solids in there, the sugars primarily, there's EC in there as well, but the taste. We're looking for we need at least an 8 or 9 bricks reading to have a decent edible strawberry. We can't get up to 12, 15, and even 16 bricks, but we need an 8 or 9. These were under 3. Red, under 3. They were so bitter, nobody would buy them. Nobody would buy them. They were going in the garbage. We did some analytical work, We didn't guess, we used the science, and you're gonna hear me talk about science this afternoon in way more detail, but we used the science to determine that they needed potassium. The potassium was non-existent. There were lots of sugars in the leaves, but they weren't able to move into the fruit. The grower went on and put on a couple foliar applications of a potassium product. Guess what? Within 7 days, we went from under 4 to over 9 on the Brix reading. We made fruit that was going into the garbage, going into one of those boxes on the side, making you money, and you're happy consumer buying your product, right? Very quickly, and it was potassium that was the deficiency in that regard. You need potassium to move sugars. All right, next, calcium. So now we're getting into, those were what I call the macronutrients. Macronutrients, macro, think big, macro. Macronutrients needed in larger quantities. Now these are the secondary nutrients. They're maybe not needed in quite the same quantities, although I think calcium is probably more of a macro than a secondary, because it's needed a lot. What does calcium do for us? Well, calcium is part of that cell structure in that it's giving us a thicker cell wall structure. If I have a thicker cell wall structure, I can have that cell go bigger without getting a thinner wall and exploding that balloon, right? And think about things like SWD. We're actually getting some good results right now on high bush northern blueberries, getting calcium into the fruit, creating a thicker cell wall structure. So SWD is less able to penetrate the berry to lay their eggs and the nice little worms that can cause problems. Calcium is a big trick to that. But we got to get it in, and I'm going to talk about that today in length, because lots of people are going to apply calcium, but it's got to get in. It's got to move the needle. It doesn't do any good just to put it on, it doesn't move the needle. But calcium is part of that trick. Same with disease management. If I can have a thicker cell wall structure, I'm going to have less disease issues. So calcium is kind of critical, but it's got to get where we need it. And that's a bit of a trick. Magnesium. Well, magnesium is part of the fuel system. In that, think of chlorophyll. Remember we talked about that big word, photosynthesis? Well, chlorophyll is central to that, right? You know when you look at your leaves and they're green? What's making them green? Chlorophyll. Chlorophyll makes the leaves green. That's where all the magic with the sun happens, with the chlorophyll and the chloroplasts, to turn that energy into food. When you look at chlorophyll, in a very simple molecular view, it's magnesium, surrounded by, guess what, 4 nitrogen. So magnesium and nitrogen are central to chlorophyll. Chlorophyll is central to making your plants green so they can produce food to produce a crop. Sulfur. Sulfur is often forgotten. And you know what? Back 30 years ago, we probably didn't need to apply a lot of sulfur. We had this thing called acid rain. We had a lot of sulfur coming in the rain. We really did, particularly around the Great Lakes where we're a fair bit. Well, guess what? We're now better from an environmental standpoint in that we don't have as much acid rain anymore, which is probably a good thing. Not probably, it is a good thing. But guess what? I'm seeing a lot more sulfur deficiency in the specialty crops than I've ever seen before. So it's a nutrient we need to manage. Sulfur is required for chlorophyll production as well and for nitrogen metabolism. A sulfur deficiency, by the way, looks very similar to a nitrogen deficiency in the crop. The primary difference is the sulfur deficiency starts at the top of the crop, in the new growth. The nitrogen deficiency always starts in the older growth first. Other than that, a yellow leaf, it's a yellow leaf. I think I need N, it's not working. Well, maybe it's a sulfur deficiency. Silica. I had to include silica. I don't know if it's a big issue here, but silica's come up a lot of times in specialty crops out in Ontario, Atlantic, and even further west from here as well. There's a big talk about silica. It's going to give me firmer fruit and everything else. What does silica do? It's what we call one of those non-essential nutrients for plant growth. Is it required for your plant to survive and live? No. Is it using it? You bet it is. Where is it getting it from? The ground. Silica is probably one of the most abundant minerals in the Earth's crust. And under the right conditions, meaning you got a healthy functioning soil and good root system, the plant will probably pull in lots on its own. It gives rigidity to that cell wall structure. The one caution I have is a lot of the products on the market today are mineralized silica And if I over-apply mineral silica versus the organic silica coming out of the ground, which is perfectly fine, but if I over-apply mineralized silica, I'm getting rigidity of that berry, that rigidity of that cell structure that makes up that berry, at the expense of cell elasticity, the stretch. So if I over-apply silica, and I've seen this on northern highbush blueberries. I had a grower out west who really went hard on the silica one year. I mean 12 applications. It was hard on his pocketbook. It was great on the other pocketbook. But 12 applications of a foliar calcium silica product. Wonderful. Those berries, they were like marbles come harvest. I'm not exaggerating, marbles. They were rock hard. Then they hit the hydro cooler. Popcorn. The skin had no stretch. It was literally watching them crack and split and wide open and turn inside out in the hydro cooler. Thousands and thousands of pounds of blueberries going to waste because the guy overdid his silica and foliar sprays through the season, created hard berries, the skin had no stretch, and we see all sorts of deformities and stuff in different crops. In apples, I see lots of cracking up at the cuticles and stuff because of over applications of silica. A little bit is good, a lot, maybe not so good. Anyway, silica. Zinc. Think of zinc like your fuel lines. The plant has these veins, this vascular tissue. That vascular tissue is how the nutrients and the sugars and the water move around in the crop, right? Well, I need good vascular tissue to move everything around. That's what zinc does. So when I say zinc, think good root system, good leaf function, good leaf size. Zinc deficiency is often characterized by really small, puny little leaves. Good zinc is big leaves. Big leaves mean big factory to make sugars. More sugars mean better fruit, right? So zinc has a role to play with your fruit by making good fuel lines. Manganese, a radiated coolant system, it has a role to play with potassium in that regard. The biggest role in my mind, it has, I'm kind of summarizing these a little bit here, please. So there are multi-functions. One of the biggest, in my mind, one of the biggest functions manganese has in that photosynthetic equation where the plant is actually taking water, carbon dioxide, making glucose, and actually oxygen and glucose. Well, part of that process, water has to split. What's water in the molecular thing? We've all heard this back in high school, right? H2O, right? That's water, H2O. Hydrogen and oxygen, H2O. 2 parts hydrogen to 1 part oxygen. Well, to turn into glucose, guess what? That has to split down the middle. Oxygen one side, hydrogen on the other. That's how glucose happens. Manganese has an enzymatic reaction that allows that to happen. So without manganese, photosynthesis isn't going to happen because the water can't split. So it's a pretty critical role for the plant making its food. Chlorine. One could argue whether chlorine is essential or non-essential. I'd probably say it's probably one of the non-essentials. However, what I will say is plants use it. And we get stuck in, particularly that you're looking at apples and stuff, we get stuck in thinking about some crops as being what we call chloride sensitive. So guess what we typically do, being human nature, we go from swinging the pendulum over here to swinging the pendulum over there. We don't often find that middle ground just by human nature, right? Well, we think about chloride sensitive crops, so let's not put on any chloride. And guess what? We often see a lot of chloride deficiencies. Chloride actually has a role to play just like potassium. And if there's a potassium deficiency in your crop, chloride can actually step in and help with that. Chloride is responsible for flavonoids. You know that taste, how good that berry is? Chloride has a role to play in that. So what we mean when we say we have a chloride sensitive crop, strawberries, maybe some other crops, apples certainly, sour cherries, absolutely. That doesn't mean we don't want any chlorides. That just means we want smaller amounts of chlorides. Don't completely eliminate them. You need some chlorides. I've even got growers now. Blueberries are seen as one of the most highly sensitive crops to chlorides that we work with, or at least that I work with. I've actually got growers that are applying calcium chloride on blueberries at low doses and getting firmer fruit, where it's actually measurable and noticed at the packing plant. So chloride sensitive doesn't mean no chloride, it means less chlorides. And this afternoon, another plant for this afternoon, I'm going to talk about a tool that will tell you where your chlorides are at and whether you can afford to put more on or not. Boron. Oh, boron. This nutrient is a really fascinating nutrient. It is a micronutrient, which means it's needed in smaller quantities. We talked about macro, right? Big. Now we're talking micro, small micro, right? Boron, next slide I'm going to get into the real epitome of a micro, but boron still available is a micronutrient. On a soil test, and we're all doing our soil tests, right? Every 3-4 years, right? Yep. Yeah, I had an apple grower out in my neck of the woods in in Kelowna, and in my mind he was an awesome grower. And he had a problem on some pears, and he called me out, Rick, I got a problem, I can't figure it out, it definitely looks nutritional. Help. First thing I like to do, give me your soil test. Let's take a look at the soil tests. He went into his office, he came out with a binder, organized for that field. He even printed off the aerial, you know, how you can go on Google Maps and get the aerial on the front of the binder with the field name on it and everything else. Nice tab. I mean, we're talking organized. And this was back in around 2020. Then he gave me the most recent soil test for that field from 1992. You can be as organized as you want, but please do a soil test every 3 to 5 years, at minimum every 5 years, preferably every 3 years. They are a treasure trove of knowledge and information for the agronomist to help you figure out your fertility program. Anyways, boron moves sugars in the off season. I say off season beyond flower bloom. So later in the season, boron has a role to play with moving that sugars out of that leaf. In the nighttime period, the plant is processing what it's made during the day. Boron has a huge role to play with that. But it takes a very little amount of boron to do that. It doesn't take a lot of boron, just a little bit of boron to do that. Where boron is really needed is coming into flower and bloom and fruit set. It has a huge role to play with the health of the anther tube, the health of that flower, the viability of the pollen. Boron can play a huge role here. Micronutrients, the last slide here are micros. So iron, think of iron as the electrification distribution system. Say that fast 4 times. Yikes. It makes the plants green. It's part of magnesium. It stimulates chlorophyll production that makes those leaves green. This is a really key nutrient because if you got an iron deficiency, and it's often determined, you got your yellow leaves, but the main veins in the leaf are all dark green still. We call that intraveinal chlorosis. How's that for a fancy word, eh? Intraveinal chlorosis. So the leaves are yellow, but the veins are still green. Could be an iron deficiency. If your soil pH is 6.5 or 7 or higher, iron is most available in low soil pHs. So if you got higher pHs, you've probably seen some of what I'm talking about. The neat thing about iron, when you put it on as a foliar spray, you get a response. Some of these nutrients are hard to notice whether I move the needle or not this one. Iron, you put an iron spray on, you'll know you moved the needle within a matter of a day or two. Those leaves will be from yellow and intraveinal chlorosis to dark green, just almost overnight. They'll perk right back up. Keep in mind, if they're not green, they're not producing food. Which means what? If the plant isn't able to produce its food, it's starving. Do you want a starving crop to produce fruit for you? What type of fruit is it going to produce if it's starving? It's going to produce not good fruit. You're going to have a lot of disease. You're going to have a lot of insect pressure. We need healthy plants to produce healthy fruit that we're going to like and want to sell, and that people are going to want to buy. Copper, transmission cooler, transfer case. It has a lot of roles to play with nitrogen metabolism. That lignin formation we get in crops, that kind of that woody texture to the fiber of the tissue. Copper has a huge role to play with that. Molybdenum. This is my favorite one. I'm going to get on the soapbox of molybdenum in a minute. Think of it as a regulator. Octane boost. It has a role to play. Again, it has a role to play with nitrogen. That nitrogen deficiency story I was telling you earlier, that wasn't really a nitrogen deficiency. It was a molybdenum deficiency. So now I got to get on my molybdenum soapbox. I apologize in advance. I do this every talk I get because this is one of my biggest pet peeves in the agricultural industry right now with our soil labs. And this is true right across North America. And it's funny, when I go overseas, when I do work in Australia, New Zealand, South Africa, not an issue. The labs here in North America do not analyze for molybdenum. It is essential for plant life. It has a massive role to play in nitrogen metabolism within your plant. You can have tons of nitrogen. You can OD on N and still have a nitrogen deficiency if you don't have enough molybdenum. Because the molybdenum is required for that nitrogen deficiency, for that nitrogen metabolism to take place. Yet North American labs aren't testing for it. Overseas, it's standard. You order a detailed soil sample overseas, you're going to have molybdenum. I had the privilege about 5-6 years ago now to be in one of our labs in Ontario. The name will remain unsaid at this time. Really good lab. You would be familiar with them if I mentioned their name. And because I figured, molybdenum, it must be a really expensive test to do for a soil test. Maybe it's like $250, $300 to test for molybdenum, in which case I could see why they're not doing it, right? Would you pay $300 just to find out what one nutrient was? Well, maybe, but likely not that much money. So I sat with the owner of this lab, and I asked him, I said, why don't you test for molybdenum? It's an essential nutrient for plant life. It's a micronutrient, and by the way, it's a true micro. Just so you know, when you do a soil test and you have molybdenum tested, most crops we're working on are looking for 0.2 to 0.3 ppm of molybdenum. That's all they need. I mean, when boron, if we're over 1 ppm, we're doing a happy dance, and we think of boron as a micronutrient. Molybdenum really is the epitome of micros. I'm not even talking 1 ppm. I'm talking 0.2 to 0.3. But that little bit of molybdenum brings everything on fire and makes it work. So I said to the guy, why don't you test for molybdenum? Is it expensive? It's about $2. My jaw, $2, $3 to test for molybdenum. I said, well, why the heck aren't you testing for it? You know what his response was? Growers, I'm sitting in front of a room full of growers here, growers aren't asking me. That's why. And I said, yeah, but, he says, and besides that, I don't believe we have any molybdenum deficiencies anywhere in North America. Now, if you haven't guessed by now, I'm a little bit of a buoyant kind of fellow. I'm not overly shy. I'm kind of an extrovert until I get home. Then my wife says I turn into an introvert. But I'm on about it. So I wasn't really shy with him when he told me that we didn't have any molybdenum deficiencies in North America. I wasn't really shy to him when I said, how would you know if you're not testing? To which I got told I'm trying to tell him how to run his company, and you can imagine where the conversation went from there. But I did still get a tour of the lab. He had somebody else give it, but he did give me a tour of the lab still. Anyways, moral of the story is when you get your detailed soil sample, every 3 to 5 years, preferably every 3, ask for molybdenum. And you're looking for a level of 0.2 to 0.3 ppm. What I'm finding on all the samples that I've done over those years, and I go back and have them look at it and have them run it for the extra $2 to $3, more often than not, it's non-detectable, meaning it's not there. Doesn't take a lot to put the molybdenum in the system that you need to move the needle. It takes very little. But how expensive is N? You bet.
Are you talking about the soil or the plant?
I'm talking about the soil as far as this testing goes. And it was plant testing that I'll talk about this afternoon that cued me in. Because that did include molybdenum. I started seeing a lot of molybdenum deficiencies in sap, which had me then go and look in the soil. But when I'm talking 0.2 to 0.3 ppm, I'm talking about it in the soil. And I'm talking about deficiency non-detectable in the soil. So what I have found since then, and this is true right across North America, and I've seen it overseas as well, is it's about as commonly sufficient as boron. Every once in a while, you win the jackpot. You got lots of boron on the ground, just what you need. Same thing with molybdenum. Every once in a while, you win the jackpot. You got lots of molybdenum in the ground. But more often than not, 7 times out of 10, your molybdenum is deficient, non-detectable, and you need to put some into the system.
So what's a good base level?
In the soil?
Yeah.
0.2 to 0.3 ppm. That's what you're looking for. So you could be putting out a 1/4 pound to 1/2 pound of molybdenum on a per acre basis. So guess what? The best way to do that is the liquid. Foliar products are the best way to do that to get the coverage you need, because you're not going to get it any other way, right? So liquid is the way to do it, whether it's through the drip If you're doing fertigation on your strawberries, you got products like our clean molybdenum, you got sodium molybdate, you got products that put on the leaf from a foliar perspective. So there are options to address it, but we're looking for a minimum of 0.2 to 0.3 ppm in the soil. And what we find in molybdenum is it gets utilized and the nitrogen gets metabolized. So it does ebb and flow, and it's one of those nutrients that we need to periodically take a check on throughout the course of the season. So if I'm deficient, I can apply and get it up. It won't stay there for the season. You'll probably have to make 2, maybe 3 applications through the season through a fertigation system or foliar, whatever works best for you. Both work, both are fine, to meet that need of molybdenum through the season. Have I answered?
Yeah, can you be too high?
Yes, you can be too high. On the fruity crops we're growing, not much of an issue of going a little bit too high. On forage crops, though, we can get molybdenum toxicity on forage crops that's not so good for cattle. So when you're talking forages, we've got to be a little bit more careful with molybdenum. But on fruity crops for harvest, there really isn't a maximum level. But we don't want to overshoot because we're wasting money too, right? Everything's got to be efficient. But having it a little bit higher than what the target ranges will be, and I'm going to get you that this afternoon, not a bad thing, because guess what? Molybdenum is a nutrient, but it's a heavy metal nutrient, just like copper and zinc. What do we sometimes use copper and zinc for, right? Coincide, copper spray, fungicidal impacts of those heavy metal nutrients. I'm selling them as nutrients, but they're heavy metals. Molybdenum is a heavy metal, so we do get the benefit of having that nutrient at the right spot in the crop, giving us some disease resistance because it's a heavy metal, giving us fungicidal activity. Is there, yes sir?
I guess it's a little bit far-ranging question, but what effect does the pH have on the uptake of molybdenum? And I guess that relates to what the plant requires, what rates it has up for a premium.
Yeah, molybdenum seems to be available at a fairly wide pH range. It's not one of those ones that, like iron and manganese, that really want an acidic, or calcium and magnesium that really want a basic. If you're around that 6 to 7.3, molybdenum is going to be readily available. Even at more acidic soils, it's fairly available at a wide pH range.
Yeah, I mean, a lot of the soils here are calcium carbonate based, or bicarbonate.
Yep.
So you have
High pH
you have
calcareous soils.
7.8 kilos, not uncommon, you know, say into like Eastern Manitoba for sure. You know,
Where I live in the Okanagan Valley, calcareous soils, we have pHs upwards of 7.8 to 8.4. Matter of fact, the highest pH I've ever measured was at home in Peachland, right behind where I live in West Kelowna. pH was 12, I believe.
Wow.
Yeah, and by the way, nothing was growing in it. Talking about sterile environment. And that was actually a homeowner. They had been driving out in the bush, saw this beautiful, rich, dark brown soil. That's going to be great in my planter beds at home. Took the truck out, loaded up, shoveled all this soil out of the backcountry. Uh-oh, what's going on there? Nothing's going on.
Just hit the space bar or enter.
Whoa. That's weird. Stop as soon as I unplugged it. Try that again.
There you go.
There we go. I'll have to go back. Oh, okay. Oh, let's do that. There we go. Okay, sorry, where were we?
Yeah, take molybdenum.
Molybdenum.
Yeah.
Yeah, so different soil pHs it's coming in.
Yeah.
But it truly is a micro.
Yeah. And another question kind of related to that is too, like, you know, being that, you know, you can mend your soils in various ways, you know, for a pH level, but,
Yep.
you know, most fruit plants, you know, like more acidic, to lean on the acidic side, especially blueberries, you know, but.
Yes, and there's multiple, yeah, absolutely.
So that, but then, you know, like the fertilizer you're using, are you using more like ammonium sulfate based or you know,
Gotcha.
half ammonium nitrate at the same
Yep,
time? So
yep, you got urea, ammonium nitrate, you got all these different nitrogen sources out
Yeah.
there. I like to hedge my bets. It's less to do with the soil pH than it is to do with nitrogen uptake and metabolism by the crop. And I'm going to explain that in a second.
Okay.
Matter of fact, there we go, my next slide, perfect timing. A lot of people like to use ammonium-based fertilizers to acidify that higher pH. And where I am in the Okanagan, our average soil pH is 7.3 to 8.2. And I told you how high that one soil was. And by the way, the homeowner, all of that stuff, won't put it in their planter beds. And all their shrubs died. And that's when I got involved and we started looking into it. So don't trust, you can have that rich, dark soil that looks beautiful, but if the pH is wrong, you're dead in the water. Literally, dead in the water. So we often talk about nitrogen sources, urea, ammonium, and nitrate. Don't use the ammonium just to acidify the soil pH. Because if your organic matter is half decent, it's going to take forever and you're never going to really succeed. You're more apt to work with the pH that you're dealing with. Work with it. Know that certain nutrients are going to be, that more higher pH calcareous soil, I know iron and manganese are not going to be readily available. Build it into your program. It's a lot cheaper than trying to change the pH. Right? Work with it. Organic manures, compost. I'm a huge fan of those. They have a role to play. I think of a customer I used to have that grew a lot of field veggies. Ted Horstein was in Cache Creek. He was one of my go-to back in the day on producing vegetable crops. Talking about calcareous soils, I'm talking 43, 5,000 ppm of calcium, 7.8 pH. Organic matter, I think it was around 1.5, 1.25, somewhere around there. In 10 years, through regular green manure rotations and just compost and things like that, his natural pH in those fields was 6.8. It can be done. But it takes time and it takes energy on your part and a commitment through manures and stuff. But the fertility itself isn't going to do it.
Well, plus when you not only manures, but if you can get things growing
Yep.
well and healthy, you've got your root system
Right.
in organic.
Now-
that always mitigates the effect of
Exactly, right? Absolutely. Now I'm going to take that healthy side and run with it for a second. We often talk about the soil nitrogen cycle, right? We put on urea, what happens in the ground? It converts to ammonium. Plant can take it up as ammonium. Matter of fact, when the plant takes up nitrogen as ammonium, it's going to regulate the uptake. The plant is actually determining how much it wants and takes only what it needs. There's a lot of these nutrient products on the market from a nitrogen perspective called stabilized nitrogen products. Super U would be one, Super Max, there's a bunch of them, Nitrosphere would be the Simplot one, there's a bunch of them out there. Those are based on that principle that the plant will regulate the uptake of ammonium. So it's urea treated with a chemical compound, so when that urea dissolves in water, once you put it on the ground, it dissolves, it converts to ammonium, and then the chemical holds it as ammonium. It doesn't allow it to convert over to nitrate. It holds it as ammonium. Two neat things about ammonium is, like I said, the plant regulates the uptake, and ammonium, NH4, positive charge. Back to soil chemistry, soil has soil colloids, the soil has a negative charge. If I don't want something to leach, it has a positive charge, it won't leach. So ammonium doesn't leach readily from the soil, so the soil will hold on to it, the plant will take it up as it needs it. Ammonium, wonderful. Now the down part about ammonium, there's always a pro, there's always a con. The down part, the con to ammonium, is that when it comes in, it comes all the way in up to the top of the plant, and then the plant has to push it down into the stem and lower parts of the plant to metabolize it and use it. So in a wetter year, ammonium's a great source. As long as it's got lots of water to push it around, move it where it needs to go inside the plant, it's great because it's ammonium. The plant can right away use it. It doesn't take a lot of energy for that plant to use it. Nitrate. Here's the bad boy. Oh, yeah, something's not right with the, we'll have to look at that.
It had flickered off and then it came back.
You're
Okay,
good, it's coming back.
okay, we'll let it come back. We'll let it cycle and see what happens. Oh boy, we went way far. There we go. There we go, perfect. No, there we go. Okay, so ammonium. Maybe this afternoon's presentation, put a data stick on the PC to see if we can avoid some of this. Nitrate is the bad boy. And what I mean by that is when nitrate comes in, it brings water with it, so it's going to make a softer fruit. And guess what? Nitrate is coming in whether the crop needs it or not. It's like me and a good wine or chocolate. You put dark chocolate in front of me, whether I'm hungry or not is irrelevant. I have dark chocolate, need a glass of wine, I'm set. Same thing with nitrate in the crop. Whether it needs that in or not, it's coming in and it's bringing water with it. Nitrate gives us disease and insect pressure. Nitrate gives us soft fruit. You put urea on, it's going to convert to ammonium, and then it's going to convert to nitrate. And by the way, that conversion is based on your soil pH. The bacteria that do that conversion, if I have a really acidic soil, it's going to be really slow. That's one of the reasons blueberries like a low pH, because they can't handle that nitrate. They just can't digest it. So they want ammonium. Lower pH soils, it stays as ammonium. That organic matter converts and releases nitrogen. It stays mainly as ammonium, so we don't have to deal with that nitrate. That's why, one of the reasons why blueberries like that acidic pH. Now here's the thing that a lot of guys don't talk about. Guess what? There's a nitrogen cycle in the plant that we need to deal with. If the plant's taking up the nitrogen as nitrate, the neat thing about nitrate is it comes right in, goes right up to the top of the plant, gets metabolized. So in a dry year, I want nitrate, because I don't need a lot of water to metabolize it. In a wet year, ammonium. And the reason I want ammonium is when the plant takes it up, if it's nitrate, guess what the plant has to do to that nitrate before it can use it? It converts it back to ammonium. It takes up nitrate, it has to convert it back to ammonium before it can use it to build amino acids and proteins and all those neat plant parts. So it needs to do that conversion, and that's where molybdenum comes into play, by the way. Molybdenum is required for that conversion. There's a reductase, an enzyme that drives that whole equation inside the plant that requires molybdenum. So if I'm getting lots of nitrate in and I don't have adequate amounts of molybdenum, guess what? It's not being efficient with that N. You're putting on way more N than you need to, likely. So we want to make sure your molybdenum is good so it can convert that over to ammonium and then amino acids and proteins. And if you're growing strawberries, what are you putting on? Calcium nitrate? Potassium nitrate? Maybe even magnesium nitrate? One of your primary sources of nitrogen is going to be what? Nitrate. So if you're growing strawberries and one of your primary sources of nitrogen is nitrate, don't you think you should know where your molybdenum's at in your soil test? To make sure that that N you're putting on is being used properly? Because quite often, that's part of the problem. And if we have to put on excessive nitrogen in the nitrate form to combat, because I have very little molybdenum in the system, well, guess what? Now I'm creating a high nitrate environment, bringing lots of water in. Water dilutes everything in the plant, so we get low sugars. Now we get a lot of disease and insect pressure. I've seen leafhoppers infest a field. We get the molybdenum up, the nitrate's down, guess what happened? The insects left. All right, right form, right place. Got to pick up the speed a little bit. I'm going long, I apologize. What time is it anyways?
You got 5 minutes.
Okay, we're gonna go fast. Pick up the rest of the afternoon cycle. Right form, right place. Basically what I'm saying here in a nutshell is the most expensive fertilizer you can buy is the one that never got in. And what I mean by that, we talk about percentages of nutrient, right? And we often think the best fertilizer has the highest percentage of nutrient. But if that high percentage nutrient doesn't penetrate, doesn't get into the crop, it's not gonna work. So as much as it's hard to believe, form matters way more than the analysis on the bag. I have seen product going out at a quarter pound an acre end up more in the sap inside the plant than 2.5 pounds of a different product. Form matters more than the percentage. Why does that matter? It's because if you're doing things like foliar nutrition, you need products that were designed for foliar nutrition. Just 5 minutes Googling and you can find multiple articles on these chelates called EDTA chelates, iron EDTA chelates, zinc EDTA chelates. Chelates were meant to stabilize nutrients in the soil so that they can stay plant available and don't get tied up with the soil chemistry. They work phenomenal in that regard. They're relatively cost effective. They're extremely available. They don't penetrate the leaf because the molecule that stabilizes that nutrient makes a much bigger molecule that can't penetrate the leaf very well. I've had growers apply iron EDTA chelate and doing work and looking at the sap inside the leaf, the needle isn't even moving. Then all of a sudden we go to a nutrient that was designed for that application and the needle starts moving. Here's an example of what I mean. We've got orthophosphate and polyphosphate, two different forms of phosphorus. Think of the polyphosphate as multiple chains of this little orthophosphate molecule. And we may have to be imaginative in looking at the slides. See if it comes back in a minute. Not sure why we're going in and out, but there we go. So we looked at the sap in there. You have to trust me. We looked at the sap in there at 3 days and 10 days post-application. The orthophosphate still had 80% more phosphorus in the plant 10 days after application than the polyphosphate. Now this was in low bush blueberries, but it shows you that the right form can really move the needle way more than the wrong form. It really does matter. Now here's the 10 days post-application. Look at that young leaf. 84% more phosphorus than in the untreated control versus 9% in the polyphosphate. 75% more phosphorus in the older leaf compared to the control, compared to only 38% in the polyphosphate. The form of the nutrient matters depending on how I'm going to use that product. And you got to rely on the crop advisor you're working with to give you guidance as to how is this product supposed to be applied. If you want to do something on a foliar, you got to tell the agronomy, the guy you're buying the product, I want to use this as a foliar. Is this good to be used as a foliar product, or is this more through the drip, through the soil? You got to find out. Now I know seaweed isn't a nutritional product, but it's a really good example of right place. You put seaweed through the drip, you're helping improve root function. Mining those nutrients out of the ground, overall root function. You put the same product, and in this case I'm talking about a seaweed species called Oscophyllum nodosum, fancy seaweed species, means it's coming off the Atlantic coastline in colder waters. You put it on through the leaf as a foliar spray, it's alleviating stress. Zinc is another prime example. I put zinc through the drip and into the root system, I'm making bigger roots. Foliar apply it, I'm making bigger leaves. Where we put the product matters. Where the nutrient ends up matters to the response we're going to get. Right mix. This is the big one. Key thing here is there are nutrients that play well together in the sandbox. There's nutrients that don't play well together in the sandbox. We want to take advantage of the ones that play well together. We want to avoid the ones that don't, because we're kind of wasting money if it doesn't play well in the sandbox together. Here are the two big key ones to remember for fruiting crops. Potassium and calcium. Guess what? They do not play well together. So during early fruit cell division, which happens right after petal fall, right? I don't want a lot of K around, because that's going to prevent the calcium from going into the fruit. It's also going to prevent and compete against the calcium for uptake, but it's going to prevent it from going into the fruit. But later, once I've got the calcium in the fruit, I need the K to get color. So there's a right time for K, and it's not during that petal fall period. Calcium and boron. Now there is a synergy. If I need boron, and Carol, because if you don't need boron, you got problems. But if I need boron, putting calcium and boron together increases the uptake 10 to 15%, just by putting them together. Huh. Pretty neat return on investment. I need both. Put them in the same tank together, because they're needed around the same time, coming into pollination and fruit set. Guess what? Increase in uptake. So there are two that get along well together. But here's my caution. If you don't need boron, you're going to create what's called boron toxicity. And boron toxicity fries cells, causes plant to rot standing on the ground. And I've seen lots of it out there, so you got to be careful. You need a little bit of boron, but you don't need a lot. That synergy between calcium and boron is lost when you get excessive boron. And it's interesting, because I was out last week in New Brunswick talking to potato growers, and McCain's is doing a big research study right now on PEI using boron to solve what's called hollow heart in potatoes. Well, hollow heart in potatoes is due to calcium deficiencies. And they're using boron because one research project showed an improvement in hollow heart with boron. Well, boron and calcium have a synergy, but it's not an infinite synergy. When boron gets toxic, guess what? If that leaf is dying, how much transpiration, how much calcium is coming in? Nada, not happening. So if I need boron, great. If I have a boron deficiency, it's impacting the calcium. If I don't have a boron deficiency, don't put it on, because it's going to hurt the calcium. Me, as I say, I can already predict before that trial for McCain's and PEI comes off that it's not going to show much help because they're ODing on the boron. They're putting boron on every spray. Doesn't need it. You're wasting money and killing your crop. So 5 R's of plant nutrition: right nutrient, right time, right place, right form, right mix. You focus on these principles, you'll see healthier crops. Farmers, that's what right in the beginning, my why. That crop just looks healthier. Why? Because we did a good job applying these. No secret to it. We just applied these as best we could. Bigger yields, not bad. Higher quality. And a really big one, because we know fertilizer ain't cheap and it's not going to get cheaper, fertilizer efficiency. We stopped wasting fertilizer. Rather than putting on all that nitrogen when I needed just a little shot of molybdenum, solve the problem. Let's be more efficient. So, on the sides table there, and I don't expect anybody here to read this, unless of course you have really eagle eyes. I put together some crop programs. And I got a program put together for foliar nutrition for strawberries, Haskaps, tart sour cherries, and Saskatoons at the back. And this afternoon I'm going to talk about those other 3. Today was supposed to be the strawberries this morning. Some of the products you're going to see in there, in these programs, you can see a product called Biomax. Biomax is a soil biostimulant. It's not on live bugs in a jug. It works with the bugs that's in your ground already. You got all these good aerobic bacteria and mycorrhizae and all these neat things in the soil. When they are firing on all cylinders, so are the roots. We want to maximize root function. This product will do that for you. And I mean, the foundation is in the roots, right? The majority of the nutrients come in through the roots. We got a product called NanoCal back there, a micronized calcium product, great through the drip. It's got this oral wet technology in it that I'm going to talk a little bit more about later this afternoon that helps ensure that that calcium is moving to the root tips. Why does that have to move to the root tips? Because the only part the calcium is coming in through the roots is through the tip of the root. It can't come in through the side of the root. It has to come in through the tip of the root. So you got to get the calcium there. The NanoCal is going to do that. Sim Spray is going to be in this program. This is your seaweed product. For stress, foliar, for root function through the drip. What are you looking for? What's this year's demand? Our foliar products are what we call DLs. You're going to see a sheet there for a product called Agro K. That's a calcium dextrolate. So our products are simple sugars. So what we're doing is we're taking the calcium and reacting it with the simple sugars dextrose and lactose, and through a fermentation process, and creating a product that is designed for foliar uptake. So the NanoCal root, really great. I got some guys that do a foliar, but it really functions through the drip. The DLs are meant to go through the leaf. Then we got some NPK stuff you'll see back there as well. Last one I want to talk about is called Transformer. This is one of the new products for us that we inherited when we became part of Rovensa Next. Transformer is a soil modifier. You put it through the drip once every 3 to 4 weeks. It reduces the surface tension of the water to improve that water's percolation through the root zone. The nutrients need to come in contact with the roots, and certain nutrients like calcium need to come into contact with certain parts of the roots. So we need that water throughout the root zone, and with your drip, it can do a cone straight down sometimes. I want that to go that way, not just that way. This product will help do that. It will help force the water to go laterally, not just vertically. By the way, it also has some alcohol solvents in it as well that will keep your emitters clean. Anybody has a problem with clogged emitters? Right? This will help with that. So it's twofold. It's helping make sure that the nutrients are being spread, and once every 3 to 4 months or 3 to 4 weeks, you can put it in with a nutrient application through the drip. It's going to ensure that they're getting everywhere throughout the root zone, and it's going to keep your emitters from clogging. And just as a side note, if anybody's doing pre-emerge herbicides, distribution of the pre-emerge herbicide through the root zone is critical to how well it's going to work. Transformer. So final thoughts. Sorry, I probably went a little more than 5 minutes. I apologize. Final thoughts. When it comes to nutrition, nutrient balances are where it's at. When I do nutrient plans and fertility products and design fertilizers, it's all about the ratios. I'm going to talk about that more when we start talking about Haskaps and stuff this afternoon. It's all about the ratios. Use testing and analysis. I mentioned soil sampling this morning. I will talk more about soil sampling this afternoon, and I'm going to talk about this thing called sap analysis this afternoon. Another tool that can guide your nutrition. Use those synergies. Take advantage of the nutrients that play well together, but avoid those antagonisms. Potassium and calcium, big one. Recognize the impact of the soil pH. We've already talked about that. It is massive. Don't try to change it as much as try to work with it. That's my message for now. Thank you very much. This is who I am. I'm here for the day. I don't think I have to run to the airport till 5. I got one more talk this afternoon. I'll be motivated because I got to catch my airplane, so I'll be motivated to be a little less wordy. My wife usually travels with me, and she usually kind of sitting at the back of the room doing this. Because as you can tell, I'm passionate. But the reason I'm passionate, the why, is I want to see you succeed. So if you have any questions and you don't want to ask them in the big group, corner me, ask me those questions. That's what I'm here for. Thank you, enjoy your lunch.
Thank you.
Thanks, Rick, that was great. Lunch today is upstairs. So you're gonna go either up the stairs or the elevator, and you're gonna turn right. And there's a whole open area with tables, so we can go in there, find a spot to sit, and then we are eating their buffet. So then you can just go and grab a plate in their buffet. There'll be a waitress or a couple there taking drink orders, so enjoy. Maybe don't leave anything valuable in here. I don't know, just I would hate for something to go missing while we're up there, because we've always been in this room, so just don't leave anything valuable, and then we will come back down here for 1:30.